Welcome back, chemistry fans. Today we are going to do the density lab. The density lab could be done with any material, but in fact, what we are going to do the density of today is metal samples. Now, I'm not asking you to get the density of all 6 of the metal samples. I am merely asking you to select one of the samples. So for today, I will choose the let's go with the copper. We all know copper looks like it's that orangish brown metal. And so we will do copper today. And there you go. You could see it. It looks dingy. It looks dirty. And it's the piping. It's in most of our water pipes somewhere in your house, getting into the feed lines. Okay, so what we got to do is we've got to do 2 separate steps. We have to get the mass of the metal, and then we have to get the density, and then we have to get the volume of that metal. So I've got this now in here. I will place my cylinder on here. It is 29.41. Let me grab a piece of paper and we will work out the math of this together. Because I'm always prepared. I can do this right now. So 21.41. So let me do this upside down with you. 21.41 grams. And then let's get the volume. 21.41. So what we have to do to get the volume is water displacement. We're going to use a graduated cylinder. I'm going to put probably just a few milliliters in here. Let's see, I'm going to estimate it. Just a guess of how much I'm going to need. I just need enough water in here to cover up the cylinder. So it looks like the height of my water is taller than the height of the metal. So I think we're going to be okay. So it looks like what I put in here was exactly 4 milliliters. So I'm going to take my metal and I'm going to slide it down the side and not allow it to escape. And what it ends up doing is it raises the water level. So it was at 4, now it's higher. So the water displacement on that caused it to go up to 6.6. It looks like 6.6 is the volume. Okay, now here's the issue. We have 2 pieces of data. One of the pieces of data has 2 significant figures. The other piece of data has 4 significant figures. How many are we going to be allowed to have in our answer? We're only going to be allowed to have 2 significant figures, but we don't cut it off until we get done with the math. So let's find our calculator. And what we're going to do is we are going to do 21, because density formula, D equals mass over volume. So what we're going to do is we're going to take this and turn this into our formula, mass over volume. So 21.41 divided by 6.6, and that is equal to, look at all those numbers, but we can't use all those numbers. So how many can we use? Only 2. So my answer is 3.2 grams per milliliter. That is the density of the aluminum. Now, here's the problem with that. The density of the aluminum should be 6.39. Well, somewhere we're off. It's not for you to figure out. It doesn't matter why the density is changed like that. It does not matter. But let's make sure that I have the right density. Let me share my screen for just a second. Let me go back and double check where I've written this down. So density of aluminum. 2.7. Oh, I'm off by a lot. Let's try 2.7. Now it's not so bad. My density is not so bad, but we're going to have to calculate the error associated with this one. So the error formula, let me write this, ERROR, so it's percent error, and that is equal to correct minus wrong divided by correct times 100%. All right, so which one of these is correct? Which one of these is wrong? Well, the correct one is the one that I looked up on the internet. That's what it should have been. So I'm going to have, whoops, let me unshare my screen. Sorry. Come back here. So what I'm going to have now is my correct value, 2.7 minus 3.2 divided by 2.7. So let's put that into the calculator now. So 2.7 minus 3.2. Now, this is an absolute value, so it doesn't matter that that is negative. That's okay. We can turn that into a positive. But I'm going to take that now and I'm going to divide it by 2.7. And what I end up with, again, is a series of numbers. But how many significant figures am I allowed to use? Only 2. So my answer is 0.19, multiply it by 100, and what I get is 19% error. All right, this is the kind of work that you are going to have to do on your own, okay? So hopefully you following along with me as for how to make these calculations. Awesome. All right, this is everything that I am wishing to share with you today. This is our density lab, and I'm grateful that you spent some time with me, and hopefully you've learned a little bit about significant figures, density, and how to make those calculations. Thank you so much. Take care. Farewell. Bye.